Welcome to Crying Out Cloud, the podcast that will make you laugh, cry, and reconsider all of your cloud security fears. I'm Eden from the CTO team at Wiz, and I'm here with my fabulous co-host, Amitai from the threat research team.
Hello.
And we are about to get into some very exciting dynamic stories going down in the cloud recently. Amitai, you ready to do it?
Yeah.
Cool. What are our stories for today?
So our first story for today is about how Okta had their support system compromised.
Was it a privilege escalation?
No, but maybe the attackers asked to talk to their manager, which is a sort of privilege escalation.
And for our second story?
So the Azure command line interface, the Azure CLI, had a vulnerability that led to credentials being leaked on CI/CD systems.
Azure is like a friend who cannot keep a secret.
Yep.
And for our third story?
Our third story is about two CPU vulnerabilities. One is called Reptar and the other is called Cachewarp.
So if anyone's a Rugrats fan, they can respond with their favorite Reptar moments in the comments.
Please do.
Okay, let's jump into it. So the first story, which is the Okta support system compromise, is super interesting. There was an unknown threat actor that got access to Okta's customer support system because what happens is customers regularly share HAR files that have like session tokens with customer support. For those who don't know, like the HAR file is short for HTTP archive, and it's basically a recording of a browsing session. So it makes sense, you're helping support, and companies ask the customer to share with them for troubleshooting technical issues, but they contain plain text credentials. So how did this unfold? How many customers were impacted by this?
So according to Okta's investigation, the actor in total managed to steal session tokens from about 5 customers, which is a pretty small number, but it's still like real customers that were impacted by this. And 3 of these
customers got their support tickets answered.
Yeah, exactly. Yeah, we don't know. We actually don't know how many of these customers were satisfied with the response they got from Okta support system, but they certainly got a response from the threat actors. Anyway, 3 of these companies, which are pretty big companies, pretty well known, they actually identified this themselves, and this is actually how Okta learned about this in the first place. So like each of these companies in turn saw that something weird was going on in their own environments, and they were like, wait, did the attacker get in through Okta? So, I mean, this has been really interesting to follow along with this. Like initially, Okta said that this had happened, and then like one by one, a few different companies released information about it, and said, yes, we were also targeted by this. Yes, we were also targeted by this. This is how we figured it out. And Cloudflare had like a sort of a ballsy move of titling their blog post, yes, once again, we detected an Okta compromise in our environment. And they also released an open source tool to sanitize HAR files, which is sort of, I guess, a subtle way of telling Okta that they should have implemented this themselves.
There's a lot of pass on that move.
Yeah, definitely. But I guess Cloudflare are a sassy company, so I guess it fits.
Maybe they're fiery. Just kidding, because they're called Cloudflare. Anyways, who did it? Do we know who the actor is?
So as far as I know, we don't know. It's possible that Okta has a bit more information that they haven't shared. Maybe they have a few more leads, but as far as I know, nobody knows. I did see a few rumors going around, basically pure speculation that this was an actor called Octopus or Scattered Spider. This was the threat actor that targeted Okta a few months ago. So there was speculation that maybe they were just at it again, and they were targeting Okta again. But I think that's basically speculation.
So if you're an Okta customer, what should you do?
So Okta customers should probably rotate their credentials just to be on the safe side. Supposedly, Okta has investigated this thoroughly, and they know exactly who this threat actor stole session tokens for. But probably to be on the safe side, it would be best to rotate credentials. And Okta, they've claimed to reach out to everyone who is impacted by this. So you probably don't need to be too concerned about whether or not you were impacted unless Okta reached out to you.
But then the other big impact is, let's say you're a company that collects HAR files. What should you do?
Yeah, so I think the big takeaway here for the industry is that HAR files, HAR files are an important potential source of information for threat actors. So it makes sense to sanitize them on your end. Like, customers shouldn't be responsible for doing this. Like, if you are asking a customer to share an HAR file in order to help them with troubleshooting or for whatever other reason,
Tanya.
companies need to take responsibility for sanitizing them, not expecting that their customers will do it.
Yeah, also shameless plug to Amitai's Twitter. He makes really cool like diagrams where he shows you visually how this went down. So if you follow him on Twitter, I'm not on Twitter, you could see a really very descriptive and beautiful diagram of this going down.
Thank you. I like using Excalidraw to make these schematics. And we'll put a link in the description of the episode if you want to check it out.
Okay, the second story is also quite interesting. There was an Azure CLI credential leak that even has its own CVE. And what happened is kind of crazy. Microsoft disclosed this vulnerability that affects the Azure CLI, and it can lead to credentials leaking. So if you're using the Azure CLI, your environment potentially leaks credentials. And the way it works is that like the Azure CLI exposes the sensitive information credentials in the build logs when they're invoked as part of the CI/CD process. So if you're doing an action, if you had an action that was doing API calls, then by default, because this was the default in Azure, it was printing passwords to log files.
Yeah.
Which, I mean, if you were doing this in your cloud environment, it's not great, but it's also not detrimental. But if this was in a public repo, it's kind of bad. Anyone can see the log files.
Exactly.
How did this come to light? How did this show up in everyone's radar?
So the Azure CLI source code is open source, and they have a repository on GitHub. So apparently, over a long period of time, people had noticed that this was happening, and they were filing reports against the Azure CLI repo, asking that Microsoft fix this. People were complaining about it. And then some researchers recently proved that this was actually really dangerous, and you could actually find a bunch of open source repos that were using the Azure CLI, and you could easily find plain text credentials in their build logs. So they wrote up about this and they reported it to Microsoft, and then Microsoft finally fixed it. And they sort of put a spotlight on this problem. And I think it's really interesting because like this isn't a typical vulnerability worthy of a CVE. Like, it could just have easily have been framed as like an insecure default or something that isn't quite a vulnerability, more like a bad usage pattern on the side of customers. Like, Microsoft could have pretty easily said that this was a customer issue and not a Microsoft issue. So it's interesting that they decided to do this. Maybe they felt that they had pressure on them to do so. Maybe this is part of their new philosophy of going for secure defaults. So I think it's a very good thing that this happened, and it's like that, not that the vulnerability existed, but they decided to fix it the way that they did. And
But it took a while.
yeah, that I mean, you could say that against them, that this did take a while, and it took a bunch of people to write about this in order for them to get around to fixing it. But I think that's true of a lot of open source projects. And I mean, you can get a lot of noise, and you have to sort of sift through it to realize what actually matters. But I think plain text credentials is pretty bad. Like, this should have been handled pretty quickly, probably faster than it was.
Do you think this is like the beginning of a new class of vulnerabilities, systemic vulnerabilities?
Yeah, I mean, it's really interesting because on the one hand, this is sort of a like it's sort of a I don't want to say a cloud vulnerability, but it's sort of like a service vulnerability in the sense that you have this weird interaction between the Azure CLI, which is like installable software and therefore deserves a CVE in the eyes of most of the world, and you have your CI/CD system, which is a service, and it's the interaction between these two that creates like the negative impact here, where you're leaking credentials in a place that you shouldn't be leaking it. And as you mentioned, if this was happening in a private cloud environment, then the secrets leaking isn't great, but it's not bad. Like an attacker can't really do much about that unless they're already in the system.
Yeah.
Hopefully, yeah, like hopefully um, this is a precedent for assigning CVEs and putting a spotlight on similar vulnerabilities like this and treating basically potential or default misconfigurations as a serious security problem that's worthy of a CVE and worthy of of shifting to secure defaults, which is what Microsoft did here.
Do you have to do anything, or just the new default setting if you're using it prevents secret from being presented in the output?
So what Microsoft customers need to do is they need to patch this, like that there is an update to the Azure CLI that changes the behavior. So you need to update it. Azure CLI has an auto update option, so you should probably enable that if you feel that it's okay and it won't screw things up in your environment. And there are also a bunch of settings you can explore that disable logging entirely, but I mean, that's like a nuclear option that you probably don't want to do.
We like auto updates, makes your life easy
Yeah.
maintenance.
Yeah.
So the takeaways are, if you're using Azure CLI, update your Azure CLI or enable auto updates so you don't even have to think about it. And then also kind of for the industry, the larger takeaway is that the defaults are quite powerful. And vendors should really be cognizant that they have millions of customers that this affects. And so it should be set up for their customers to succeed and be secure.
Yeah. Secure defaults are really important. This is something that CISA has been advocating for. And it's something that Microsoft has said that they will invest more in than they have in the past. And I think it really makes sense for things that are at like Azure scale or AWS scale or GCP scale, things that are like have tons of customers and tons of instances. Even if you have 1% of your customers that are making a mistake by not enabling secure settings, that's like thousands or tens of thousands or millions of instances, right? So that's why secure defaults are so important, because the edge cases become can be in the millions.
Okay, next story are the CPU vulnerabilities, Reptar and Cachewarp. These two are disclosed. Cachewarp affects AMD processors and Reptar affects Intel processors. They're kind of a part of a bigger trend of just like big CPU vulnerabilities that show up every not so distant often with a big logo, and everyone gets really like excited and riled up about it because CPU vulnerabilities, kind of like what we were just talking about with secure defaults, they affect millions, if not billions of machines worldwide. Like multiple generations of processors are impacted. And the other part of them that's worth noting, and we can go into this deeper, is that they're historically quite hard to exploit. And so like threat actors aren't running and exploiting them on a daily basis.
Yeah, like it's not like you see this sort of going into every threat actor's arsenal, as far as we know. They do make a lot of noise in comparison to how little damage they end up doing. And moreover, they also like this is I'm not saying this to blame the security researchers that find these things, obviously, but they do tend to lead to slower performance because oftentimes these vulnerabilities are in places where, in order to fix them, you need to take a performance hit to your CPU because they're in all sorts of shortcuts and tricks that processor.
Things are slow, blame the researchers.
Yeah. So, like, I'm not saying that these shouldn't be fixed, but there is an argument to be made that the cost to performance might outweigh the potential security cost of leaving these vulnerabilities unpatched.
Mhm.
And I'm not sure that we're there yet, but it's definitely an argument that we're probably going to have as an industry at some point. Because I mean, when you really want your computer to go fast, then if you're not connected to the internet, then maybe you don't care if you have a few vulnerabilities in your CPU. Like I think that is a question that people need to ask themselves.
And kind of pivoting to these specific ones, do they impact cloud customers?
That's a good question. So for most CPU vulnerabilities, you need to have code execution on the host, or in a VM that has direct access to the host, or you need to be able to execute code from within a virtual machine in a way that you can reach what's going on the host. Now, on many like home computers or on-prem servers, that might be possible, but in cloud environments, it's pretty unlikely at this point because for a few reasons. One is the cloud providers do a lot of work to prevent sandbox escape from within virtual machines, and they have mitigations in place that sort of make a lot of these vulnerabilities ineffective by default. Even if these vulnerabilities aren't patched, oftentimes they can't be exploited against these mitigations. And the second reason that in the cloud it's not of much concern is that, like in the case of Reptar was discovered by Google, and they patched their entire fleet of servers in GCP.
Rugrats invented Reptar, but yeah.
Yeah, sorry. First it was Rugrats, then 30 years later, Google discovered Reptar as well. And then they patched like everything in GCP before this was even published. So if you're using GCP, you don't have to worry about this, like even from the moment it's published. And the same goes for AWS. Like they patched this stuff really, really quickly. So you don't really need to worry about it if you're in the cloud.
Same does not go for Azure.
Someone paying close attention to this podcast might notice that I didn't mention Azure here, and that's because, as far as I know, they haven't said anything about this. It's possible that they're just not using CPUs that are affected by this. I don't think that makes sense, though. I'm guessing they did do something about this, but they haven't like released an advisory or any announcement saying that they have. Maybe they have, and I just didn't find it. I mean, I did look, but if anyone wants to prove me wrong, then please comment on the video.
But besides the Azure question, it is like a benefit, all of it, of being in a cloud environment, a huge advantage that someone else runs your server fleet. So you can pretty much ignore this, unless of course you're using like a bare metal server.
Yeah, and the fact that everything is within a virtual machine, which automatically makes it measurably safer than if it was running on bare metal.
So if a customer sees a vulnerability finding on this, first of all, will they? And if they do, should they ignore them?
So like if you're scanning your environment for vulnerabilities, as most cloud customers do with some solution or other, they might see vulnerability findings. For example, if they're using like a Linux distribution. So Linux distros often come with a microcode patch, meaning that it's something that when Linux boots, it basically patches the processor in memory. So if they're scanning which packages are installed on their machines, they might, and they're using the older version of Linux in the cloud, then they might get a vulnerability finding, like they might get an alert that they are vulnerable to one of these two vulnerabilities. Now, the thing is that they can safely ignore this unless they're running on bare metal, because one, as we mentioned, the cloud providers, Azure probably, AWS and GCP definitely, have already patched against this on the host level. And secondly, you can't patch a CPU vulnerability from within a guest virtual machine. Like you can try to apply the patch, but either nothing will happen or you'll get an error. And again, you can't touch the CPU from within the guest virtual machine. So generally speaking, unless you're seeing it on a bare metal server in the cloud, you can safely ignore findings related to this vulnerability.
Mazel tov. Yeah, so that's the takeaway. Use the cloud, and if you are using bare metal servers, check which CPU you're running on and apply the microcode patch if necessary. Cool. Those are our stories. That's what we wanted to tell you. Should we do a little podaways as a summary to our listeners of what they should know and what they should do?
Yes, we should.
First story, Okta support system compromise.
So if you are an Okta customer, you should probably rotate your credentials to be on the safe side, but you can probably assume that if Okta hasn't contacted you about this, then you're fine. If you are a company that is collecting HAR files or any other type of file that might contain passwords or credentials or session tokens or whatever, for troubleshooting purposes or anything else from your customers, it's very important that you sanitize them and take responsibility for this and not expect your customers to do it.
For the second story, the Azure CLI credential leak.
So practically speaking, it's important that you update your Azure CLI. I will say that it makes the most sense to prioritize patching this where the Azure CLI is going to affect build logs that are potentially public. For example, if you're using the Azure CLI in an open source project, then you definitely need to patch. If you're using it for something internal, then maybe it doesn't matter as much. Or at least we can say that you can deprioritize patching there and wait until you want to patch whenever. And secondly, defaults are incredibly powerful, which means that secure defaults are incredibly important. And vendors need to do more to make sure that their customers are protected by default. And I think Microsoft made a very good choice by fixing this and by assigning it a CVE. And I hope they keep up with this precedent, and I hope other companies follow suit.
Me too. And for the Reptar and Cachewarp CPU vulnerabilities.
So as you mentioned, go cloud or go home, go cloud or go on-prem. No, don't go on-prem, go cloud. And unless you're using bare metal servers, if you're a cloud customer, you don't really need to worry about this because the CSPs got you covered. And if you are using a bare metal server, or if you are an on-prem customer who is concerned about their on-prem fleet, then you should check which CPU you're running on and apply the microcode patches if necessary.
Awesome. That's it.
And watch Rugrats.
Oh, and watch Rugrats. You know, the world is a better place for Rugrats. Okay. That's it for this episode. Crying Out Cloud, the Thanksgiving edition. Presented by the cloud security company Wiz. If you enjoyed the show, which we really hope you did, be sure to subscribe, give us a rating, and remember, unlike your IAM policies, more stars is better. And as always, if your cloud security strategy is making you cry, don't worry, just cry out cloud.
Security.